Hello students, welcome to another session of this integral calculus. In this session, we will be discussing integrals of some particular functions. So here, from the point of examination, you will be asked one of them to prove. So there are 6 standard particular functions in this form. 1 by x square minus a square minus x square, that's 1 by x square plus a square, 1 by square root of x square minus a square, and this one. Please note down this and we will prove these one. And in the examination, you will be asked to prove as well as you will be given one small related example. So we will discuss in detail. So better you note down these 6 integrals. Okay, pause the video, better you take screenshot and I will be proving these. Okay, so let's have first one. So in the exam you will be asked in this form. The question will be in this form. You will be asked question in this form. Integrate integrate 1 divided by x square minus a square with respect to x, and along with you will be given one example. Hence, evaluate integration dx by x square minus 16. Okay, so we'll discuss few more examples. So this is a sample one. Okay, now see here, first you have to take I is equals to, let us call I is equals to integration of 1 divided by x square minus a square into dx. Okay, now this can be done in 2 ways, by considering partial fraction that we are going to study in the next session. Okay, so but right now, so as you don't know the partial fraction, so first what I do is multiply and divide by 2a. Remember this. Okay, so the reason is you will going to understand in the next step. So what I did, I multiplied and divided by 2a. Okay, in the denominator x square minus a square, I write it as x plus a x minus a into dx. Remember this, a square minus b square is a plus b a minus b. So I have factorized this. Further, keep in mind, in the numerator I have to convert terms of the form x plus a x minus a. So 2a can be kept as a plus a. It is x plus a into x minus a dx. Okay, which is equals to 1 by 2a. What I do in the numerator, add and subtract x in the numerator. In the numerator you add and subtract so as to get terms like this. So what I do is I write x plus a minus x plus a. Okay, so I have added and subtracted x whole divided by x plus a into x minus a. Integration into dx. Okay, further 1 by 2a x plus a as it is. I take minus common from this because I want terms like x minus a. So if I take minus common, I can write it as x minus a. Okay, from this minus taking common, it becomes plus. So it is x plus a x minus a dx. Okay, now separate, okay, this divided by this. If you separate, when you divide this by this term, this x plus a cancels, so you left with 1 by x minus a. In this case, if you divide this by this, x minus a cancels, 1 by x plus a remains. Okay, now directly, as I mentioned, derivative of this is 1. Okay, so you can keep, if numerator is the derivative of denominator, you can keep directly, it is log of x minus a. Similarly, integration of this, integration of 1 by x is log x. In the same way, integration of 1 by x plus a is also log of x plus a plus constant c. So which is equals to 1 by 2a, and you know log m minus log n is log m by n. So you can write it as log of x minus a by x plus a mod plus c. Okay, because log m minus log n, because log m minus log n is log m or n. Remember this. Okay, so this is your integration of 1 divided by or dx divided by x square minus a square. Do remember this. After this, you are asked to evaluate one integral. Okay, so further you are asked to this, you are asked to evaluate this dx divided by x square minus 16. Okay, so dx divided by x square minus 16 means 4 square. Okay, now this is of the form dx divided by x square minus a square. So it is 1 by 2a, that is 1 by 2 into a means 4 into log of mod x minus a, x minus 4 by x plus 4 plus c. So you can 2 into 4, you can write 8. Okay. Now see, sometimes you will get like this. Suppose if this is the case, if you are asked this, suppose if you get a case like this, x minus 3 whole square minus 9 or 25. Okay, suppose if this is the case, then how to do it? This can also be kept directly as 1 by 2a. This you treat as x square. So if you substitute here, look at this. If I take it as I, this is your first one. And suppose if this is the case, what I do is, if I put x minus 3 is equals to t, what you will get? Its differentiation. If you differentiate this, so you will get 1 is equals to dt by dx and dx is equals to dt. So what I becomes it is dt by t square minus 25. So which is equals to, it is of the form a square x square minus a square. So it is a square means 5 square, 25 is 5 square. So I can write 2 into 5 into log of t minus 5 by t plus 5. Okay, so and t is what? Your t is x minus 3. So it is x minus 3 minus 5 by x plus 3 plus 5. Okay, so see here, directly you can also write. So if you get like this, see here the final answer. This is for x square minus a square. Okay, so what you got, this is your x minus a by x plus a 1 by 2a, provided the coefficient of x should be 1. Illi enadru 2x alla idre, so you need to substitute. Okay, so look another example. Suppose if you are asked to evaluate this, suppose if you come across this dx by x square minus say 6x and minus say 4, say 3, you can write 3, let us take it as 7. Okay, suppose if you come across this, if you are asked to evaluate this, let us call it as I is equals to dx divided by x square minus 6x minus 7. Okay, now see here in the denominator you try to convert it in this form. You have to express it in the form of x minus a whole square something b square. Okay, now what I do is, there are various techniques to convert it by completing square also. See here, I write it as x square minus 2 into 3 into x I write. This is of the form a square minus 2ab, this minus 7 as it is I will write. Okay, so now it is of the form a square minus 2ab, that you know this. Write on this, please note on this. If you have a square minus 2ab, to make it perfect square you need to add b square to this. Okay, so here I have x square minus 2ab, so you need to, that is a square minus 2ab, you need to add some extra term and subtract that much. So b is 3 here. Okay, so in the denominator I do one thing, add and subtract 3 square, because this is your 2ab form or ba form. So dx divided by, this is x square minus 2 into 3 into x plus 3 square minus 3 square and this minus 7 as it is. Okay, so this is nothing but, now this is a square minus 2ab plus b square from here to here. This is your x minus 3 whole square. If we expand this you will get this, and here it is minus 9 and minus 7. 3 square is minus 9. And this you will get dx by x minus 3 whole square minus 9 minus 7 is minus 16, and minus 16, that is, I will write it as a 4 square. Remember this, because minus 9 minus 7 equal to minus 16, and which is your minus 4 square. Okay. Now directly use the previous result. It is of the form 1 by x square minus a square. So it is 1 by 2a into log of x minus 3 minus 4 by x minus 3 plus 4 plus c. If you want further, you can write it as more simplified form. It's a 1 by 8 log of x minus 7 by x plus 1 plus c. Okay, we will be dealing with few more examples when you complete all the standard forms. Okay, so right now let me prove all the 6 results. So here is the second one. Integrate 1 by a square minus x square with respect to x. Hence evaluate, I will be giving one small example. Hence evaluate integration dx by 25 minus x square. Okay, so as earlier, let us call I is equals to integration 1 by a square minus x square dx. Okay, as earlier, multiply and divide by 2a. It is 1 by 2a divided by, and factorize this. A square minus x square means you have to write a plus x, a minus x into dx. As earlier, like how you did in case of first one, 2a I have to write it as a plus a divided by a plus x into a minus x dx. Okay. Now add and subtract. Add and subtract x in numerator. Okay. So see here what we will get. It's a 1 by 2a integration of, I do like this, a plus x plus a minus x. I have added and I have subtracted. Okay. So divided by a plus x, a minus x dx. In the last problem, we took minus common. Here no need, because already it is ready made. We have a minus x, a minus x, a plus x, a plus x. So simply separate them. So a plus x by this gives you 1 by a minus x, and this divided by this gives you 1 by a plus x. Okay, if you separate them, you will get this. Now which is equals to 1 by 2a, carefully remember this integration of 1 by a minus x. So what is the derivative of this? Derivative of this is minus 1. Okay, so in order to write its integration, you need to multiply and divide by minus, or you can write integration of log of a minus x is coefficient of x is minus 1. So I can write here plus, see here, integration of this is log of a plus x. Better you write in the form of mod. Okay, we generally put mod log of a plus x plus c. Okay, why this is minus means coefficient of x is minus here. So whatever the coefficient of x, we divide it by that. So ಇಲ್ಲಿ minus 1 in the divide ಮಾಡಿದ್ರೆ minus 1 you will get this. This is the major change as compared to previous one. Okay, so this is 1 by 2a. Okay, this is log m and this is minus log n. So log m minus log n is log m by n. So this is your m, this is your n now, because minus is here. Okay, so this is a plus x by a minus x plus c. So this is your integration of dx by a square minus x square. Please note down this. Okay, so you are supposed to prove as well as remember. In most of the cases you will get this. Okay, now further you are given one example to evaluate. Further integration dx by 25 minus x square is given. So which is equals to dx by 25 means 5 square minus x square, and now this is of the form a square minus x square 1 by. So it's 1 by 2a. 2 means 2 into 5 log of a plus x, that is 5 plus x by 5 minus x plus c. Okay, so note down this. Similarly, suppose if you get this one, dx by 9 minus x plus 3 whole square, in this case also. Okay, so derivative of this is 1 you will get. So if you put x plus 3, dx will be dt. Okay, so you will get, it can be written as 3 square minus x plus 3 whole square. So directly you can write 1 by 2a, 2 into 3 log of a plus x, a plus x means x plus 3 divided by a minus x. Okay, plus see, I had given a sample example. Okay, so you may take any other function. We will be dealing with this much in the next session. Okay, let's have another question, that is question number type number 3. Right, integrate 1 by x square plus a square with respect to x, and hence evaluate integration dx by x square plus 64. I am taking small examples. Okay. Let us call. Let I is equals to integration 1 divided by x square plus a square dx. Okay. In all the previous two problems, we had minus out here middle, so we could able to factorize that. So ಈ ಸಿಚುವೇಶನ್ ಅಲ್ಲಿ ಇದನ್ನ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅದಕ್ಕೆ ಯು ಡೋಂಟ್ ಮಲ್ಟಿಪ್ಲೈ ಇಟ್ ಬೈ 2a. ಸೊ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬೇಕು. ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಾ ಯಾವ ಥರ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬೇಕಂತ. ಸೊ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್ ಬಂದಾಗ, ಓಕೆ, simplest form of this can be converted by substituting x is equals to a tan theta. Remember this, okay, because 1 plus tan square becomes secant square. That is the reason. So this implies x by a is equals to tan theta, theta is equals to tan inverse of x by a. Now from this, if you differentiate this, I will do it because I need to obtain the value of dx. Now x is equals to a tan theta. Differentiate with respect to either theta or x, no problem. If we differentiate with respect to theta, what will get? Dx by d theta is equals to a into derivative of tan theta is secant square theta. So d theta this side, so dx is equals to a into secant square theta into d theta. Okay, so see here, dx is this much and this is your x means a tan theta, a means a square means a square as it is. So therefore I becomes in the numerator we had dx, that is a secant square theta d theta, this is your dx, divided by x square. Okay, x square means x is a tan theta plus a square. Remember this, what we had there, it is dx by x square plus a square. Okay, this was the given. So dx means this much, x square means a tan theta whole square. Now simplify this, a secant square theta d theta whole divided by, from this if I take a square common, okay, a square is here as well as here. So if I take a square common, what you will get? You will get tan square theta plus 1. Okay, remember that a whole square is there, so a square can be taken outside. So which is equals to 1a cancels, so 1a remains in the denominator, so 1 by a secant square theta by 1 plus tan square, again it is secant square theta, that is known to us. Okay, because 1 plus tan square theta is secant square theta. You must be good at trigonometric identities. Second square cancels, you left with 1. Okay, so second square cancels. 1 by a and integration of 1 with respect to theta. Integration of 1 with respect to x is x. So integration of 1 with respect to theta is theta plus c. Now see what is your theta? Your theta is tan inverse x by a. So I replace that. This implies 1 by a tan inverse x by a plus c. So this is integration of dx by x squared plus a squared. Do remember this. Okay. Integration of dx by x square plus a square is 1 by a tan inverse x by a plus c. Okay, so we had an example there. Suppose if you have this, what we had there, it is x square plus 64 we had. Okay, 64 means 8 square. It is dx by x square plus 8 square. So according to this you can write it's a 1 by a means 8, tan inverse x by 8 plus c. Okay, let's have type number 4. Okay, we'll be doing problems on this in the next session, not to worry. So question number 4th or type number 4 you can say. Integrate 1 by square root of x square minus a square with respect to x. Okay, so let I is equals to, I can write dx divided by square root of x square minus a square. Okay, so again you cannot factorize this, outside root is there over the root, so substitution is the only way. So whenever you get x square minus a square, remember that x square minus 1 is tan square. Okay, so make substitution. Put x is equals to a sec theta. Okay, and this implies sec theta is equals to x by a and theta is sec inverse x by a. Remember this because we want theta value. Okay, so now differentiate this with respect to theta. So dx by d theta is equals to, what will get, a as it is, integration of, that's derivative of sec is sec into tan, so sec theta into tan theta. So from this we can obtain the value of dx. So dx is a sec theta into tan theta. Okay, now substitute in this. Okay, let me write that I, whatever I had, your I is this much, dx by square root of x squared minus a squared, which is equals to dx means this much, a sec theta tan theta whole divided by square root of x means a sec theta. So I can write a square secant square theta minus a square as it is into d theta. Okay, because dx is a sec theta tan theta into d theta. Okay. So simplify this. A sec theta tan theta whole divided by, if you take a square outside the root, you will get a. Okay, take a square common and outside the root, so you will get a. Inside you will get secant square theta minus 1 d theta. I hope you agree. Now a cancels. So here sec theta into tan theta whole divided by integral, that's square root of sec square theta minus 1. So sec square theta minus 1 is tan square. So under root tan square theta d theta. So square root of tan square means tan. So this tan cancels. So you're left with sec theta d theta. Okay, remember that square root of tan square is tan theta and this tan theta cancels. Now integration of log with respect to log theta with respect to theta, that is known to you. It is log of sec theta plus tan theta plus c. Okay, integration of log is sec plus tan. Now you need to convert it in terms of x. Okay, so log of sec as it is, because we have replaced x as sec, so keep sec as it is, and tan in terms of sec, you know this, tan square theta is secant square theta minus 1, whereas tan means square root of sec square theta minus 1. So I can write this as secant square theta minus 1 plus c. Now you know the value of sec. Replace sec theta is equals to x by a. Okay, why? Because you made this substitution. Look at this. Because you made this substitution, x is equal to a sec theta, so sec theta is x by a. Okay, so we need to convert in terms of x. So this gives you log of sec means x by a, square root of sec square means x square by a square minus 1 plus c, which is equals to log of x by a, take LCM here, it is x square minus a square whole divided by a, I write, okay, outside the root it will be a plus c. So it is log of x plus square root of x square minus a square whole divided by a. A is common denominator. Okay, which is equals to, I can write it in the more simplest form, x plus square root of x square minus a square. Okay, it is of the form log m by n, means I can write log m minus log n. So I can write it as log a minus log a plus c. Okay, now see here, c minus log a is a constant, so I can keep it in another form, standard form. It is log of x plus root of x square minus a square plus some big constant. I can write c or k, whatever. Okay, so where c stands for, this constant stands for, what are I can call c dash also, no problem. It is this c minus log a or minus log a plus c. I have treated this as a constant. So please remember this, integration of dx by square root of x square minus a square means log of x plus root of x square minus a square plus c. Okay, let's have one small example on this. Okay, see here, if you get situation like this, integration dx divided by square root of x square minus say 9. Okay, so immediately you can write it as, this is your 3 square, so it is dx by square root of x square minus 3 square, and you use the result, it's log of x plus square root of x square minus a square plus constant c. Very simple. Even if you get this, dx divided by x minus 5 whole square minus say 16 and square root. Okay, so square root of this, suppose if you get, you can also write it as immediately, it's log of x means x minus 5 plus square root of x square means x minus 5 whole square, 3 square means this is actually 16 is 4 square, 16 means 4 square, so you can write 4 square or 16, doesn't matter, plus c. Okay, so we will be dealing with such examples in the next class. First we have to finish all the 6 integrals. Okay, now here is 5th one. Integrate it's 1 by square root of a square minus x square with respect to x, and evaluate say dx by square root of 36 minus x square. Okay, so again you have to go for substitution. Let I is equals to dx divided by square root of a square minus x square dx. That is, dx is here. Now whenever you get a square minus x square, bring in your mind 1 minus sine square. Okay, so 1 minus sine square is cos square. So adike here you need to substitute x is equals to a sine theta. Okay, that we have studied in inverse trigonometric functions, how you can express this in its simplest form by substitution. Okay, so this gives you Sin theta is x by a. So theta is sin inverse x by a. Okay, I need it at the last stage. So remember this. Now differentiate this, because we need to obtain the value of dx. Differentiate with respect to theta. So dx by d theta is a into derivative of sine is cos theta. Okay. This gives you dx is equals to a cos theta into d theta. Okay. Now see here what it becomes. In this you have to substitute. Dx means a cos theta d theta. A square minus x square means square of this. Therefore I becomes, let me write the I. Actually we had this. Okay, this is your I. So dx is a cos theta divided by square root of a square minus x square means a square sin square theta, because x is a sin theta, which is equals to a cos theta d theta divided by, take a square common, that is under the root a square means after taking out it becomes a. It's 1 minus sin square theta. Okay, which is equals to a cancels. So we left it cos theta d theta divided by square root of 1 minus sin square. You will get under root cos square theta. Okay, now see here, cos and under root cos square means its cos cancels. So you left with 1 d theta, and which is equals to integration of 1 with respect to theta is theta plus c. So theta is your sin inverse x by a plus c. So please remember this, integration of dx by square root of a square minus x square is this much. Okay. Okay, so we had an example there. Integration dx by square root of 36 minus x square. Yes, simple one. 36 means 6 square minus x square. So directly can write the result. It is sin inverse of x by 6 plus c. Okay. So let's have another last type, that is sixth one. Integrate question numbers, that is sixth form. Integrate one by square root of x square plus a square with respect to x. Okay. So as usual, let us call I is equals to integration of this square root of 1 divided by square root of x square plus a square. Okay. Now whenever I said if you find x square plus a square, put x is equals to a tan theta. X equals to a tan theta, and from this you can obtain the value of theta. So tan theta gives you x by a, and theta is tan inverse of x by a. Okay. Now differentiate this. Okay, you have to obtain the value of theta, dx. Differentiate with respect to theta. So what we will get, dx by d theta is equals to a into derivative of tan is secant square theta. Okay. And this gives you dx is equals to a secant square theta d theta. Okay. So therefore I becomes, I andre ಏನಿದೆ, let me write, we had this dx divided by square root of x square plus a square. This is your I. So make the substitutions. Dx means a secant square theta d theta. In the denominator, square root of x square. X square means a square tan square theta plus a square. Okay. A into secant square theta in the denominator, what common you have? A square. So when you take a square outside the root, it becomes a. So a into square root of tan square theta plus 1. Okay. A cancels. Integration of secant square theta by, so square root of tan square plus 1. 1 plus tan square is secant square theta. So this secant square theta by square root of secant square theta. So I'll have secant square theta by sec theta d theta. Okay. So one sec cancels. You left with integration of sec theta d theta. Okay, now tell me the integration of sec theta. It is log of sec theta plus tan theta plus c. Okay. Now you made a substitution in terms of tan. So I need to convert this sec in terms of tan. Okay, please note down this. Tan is known to you. Tan is x by a. See here. Tan theta is x by a. So we need to obtain the value of sec theta, and that is known to you. See here, this is known to you. Sec square theta is 1 plus tan square theta. So whereas sec means it is square root of 1 plus tan square. Okay. So what I do is, this sec I write in terms of tan. This is square root of 1 plus tan square theta plus this tan theta as it is plus c. Okay, because we know the value of tan, that is the reason. This is log of square root of 1 plus tan theta is x by a, so it is x square by a square plus x by a plus c. Okay, I hope you got this, because tan theta is x by a, because tan theta is x by a. So as earlier, take the LCM. It is square root of, you take LCM here, you will get a square plus x square whole divided by a, you will get, because out of the root it is a. Now you can write it as its log of, so common denominator you have a, it is a square plus x square plus x plus c. So log m by n is log m minus log n. So I can write it as, okay, so this you have to write I will write it as I equals to log of square root of a square plus x square plus x minus log a plus c, because log m by n is log m minus log n. So I can write it as more standard form, log of, it is x plus, you can write a square plus x square as x square plus a square minus or plus, this is a full constant, I can write it as some other constant c dash, and this is your integration of dx by square root of x square plus a square. Okay, where c dash stands for here, where c dash stands for minus log a plus c. So please remember this also, this is again one of the standard result. So let me have one small example on this. So suppose if you get a situation like this, dx by square root of x square plus 9, so you can write as, okay, this is your a square, so which is log of x plus square root of x square plus 9 plus c. So very simple, you have to remember. So this is all about these 6 special functions. So in the next session we will be dealing with problems on this. So please do practice this, and definitely you are going to get 5 marks on this. So take care.